Chen. I'm a computer scientist at the Naval Research Lab, and I'm going to be talking about the work that we've been doing with the Johns Hopkins Applied Physics Lab on Kerberos and integrating measurements and integrity measurements using TPM into Kerberos. So just a quick outline of I'm going to talk about who we are quickly and what led us to start this project and work on it. And just to have everybody on the same page, and I apologize if you already know what this is I'm going to give a very brief overview of what Kerberos is. And then we'll talk about not exactly what TPM is, but what parts of TPM we're using for our purposes, and especially the AIK quote functions. And then I will talk about what we integrated into Kerberos and what modifications we've done. I have a very short demo, which you will need to see, and then we'll talk about results and a lot of future work. So, as I said, I'm a computer scientist at the Center for High Assurance Computer Systems at the Naval Research Laboratory. One of the functions I serve as the Navy representative under the U.S. government umbrella to the TCG, and I've been working on various trust computing projects for several years now, including secret bias, hardness encryption, various OS techniques, so anything that you can do with integrating TPM into security schemes. And I've been collaborating with Dr. David Chen here and Peter Cruz and James Marlowe, APL, and they have a lot of experience working with different TPM-related projects, and not only do they share TCG activities, but also they have a lot of project and research experience, both in corporate and government experience. So what led us to start this project? And we were thinking about the fact that the problem is that the platform integrity state is not considered to make accidental decisions to network. So you can authenticate it and you put in your password, so you can prove that, presuming that you did not give out the password, that if I connect to a network and I didn't give the password to anybody else, that it is actually me who's connecting. But what happens to the platform? How can we know that this is the platform you're connecting to the network is also authenticated and is something that has been allowed or that it is in a good state? So there's a need for a good mechanism to exchange this kind of platform integrity information along with authentication information. So you have this additional security verification when you connect to the network. And so when we were thinking about this, we said, well, we need something, we would like to do something that is a well-established protocol that has already been implemented everywhere, so maybe we can add stuff to it. And also, we would like to use some way of gathering integrity information that is also widely deployed, that does not require additional modifications to hardware, something that is already out there that you can use. So this is where TPM and Kerberos pretty much came together and said, well, can we use those two things together? Because Kerberos has been around for a very long time. It's pretty much the mother of single sign-on protocols. And it is open source, it's used by many, it has a plugin mechanism where, and open source, I mean the Linux version, of course, it has a plugin mechanism where you can add your own code to do the things that you would like to do. And, trusted platform modules have been deployed. There's more than, according to TCG, there's more than 500 million PCs out there that already have them. So it is not, it is very reasonable to assume that a lot of computers will have them already. So, and also we started with sort of this established background research, and Miner did a little bit of pre-application plugin research, and when I was collaborating with them, I took their idea of creating a pre-authentication plugin. So we went with that as our starting point for this project. So the big picture is this. You have a client that has a TPM-enabled computer. It wants to connect to this resource. and it connects to the Kerberos Key Distribution Center, and it not only supplies authentication for the user, but also supplies the integrity information, authentication information for the platform. And so the ticket is granted by the KDC only if identity and integrity are verified. So the client then can present this ticket to the resource, and the access is granted optionally with additional integrity verification again. So this part is really not changed. The initial authentication part is where this additional integrity information is added. So before we go any further, just so we're all on the same page, this is what Kerberos does without us modifying anything. So we're assuming there's this initialization step where the client is registered. These two, this is a ticket granting server, and then the authentication server, this is our key distribution center that I was talking about. So the client initially registers with the authentication server, so this is where you establish the principal is who you are, and then the realm is kind of like a domain, and then you establish a password. So as soon as the initialization is done, then when the client would like to connect to a service, the first thing that happens is it sends the authentication to the authentication server a request, which if the a password doesn't verify, then that's it. So if it verifies, then the ticket granting ticket is given to the client. This proves that the client has been authenticated. So then the client, if they would like to access the service, they would connect to the ticket granting server, give them that ticket granting ticket, and the server will give them back a ticket to access this resource. And then the authentication, then the client presents the ticket to the service, and the communication session starts. So what did we leverage? We decided that TPM is a really good solution. It can be hardware or virtualized. The TPM stores integrity measurements in platform configuration registers. So the PCRs are not updatable during the. You cannot change the value of the PCR. The only thing you can do is extend it. So the extend operation is you take your current value and the value you would like to extend the PCR with, and you take a hash of both, and that's the new value of the PCR. There's only one PCR that can be updated, can be changed, and that's during normal operation of the computer system. That's PCR 16, and it's used for testing purposes. And the reason why I mention this is because we do use it to change the system state and for testing. PCRs are updated on every boot. The internal TPM key that we use an internal TPM key to sign all the measurements, and I'll talk more about what a TPM code is. We will have a whole bunch of PCRs that we use for external attestation, and these are the ones that we picked for this demo. This is not a set in stone recommendation. This is just what we decided to pick this time. You could use any number of PCRs, but we use 1 through 5, which are the BIOS, the option ROMs, and the bootloader, and corresponding configurations, and then PCR 16 because we can change it and that's change the code. So an attestation identity key is a special key inside the TPM. It is a non-migratable TPM resident RSA key that is used for platform authentication, and it is a signing key, but it's not only just a signing key. It is only designed to sign a TPM-specific TPM structure that originates in the TPM. It's called the TSS validation structure, and I'll show you what that is in a second. The public portion of the EIK would be sent to the Key Distribution Center at the registration time. So the KDC will have the principal realm and the public key of the client at the registration step. So what is a TPM code? TPM is used to ensure the integrity and the trust of the integrity measurement. So the quote represents the state of the platform, and it contains the PCR values that are signed by the AIK. So it can be verified with the AIK's public key component. So basically, the way to create a quote is you create a PCR composite object with it has these arrays of hashes in the digest. So the hashes are the PCR values, and then there's their composite digest level. So we create this object, we select the PCRs that we want, and then we call the system from the trusted software stack. There's a function called TPM. And the result is this TSS validation structure that has all of this information. It has the PCR composite value, it has the signature in it, and it has all the other fields where you can put other things that you would like, for example, knots, which we can prevent replay attacks. And this is the structure that the AAK can sign. So what did we change in Kerberos? We changed the pre-authentication plugin. The initial client request is rejected. So if the password is verified, the server says, okay, that's fine, great, your password verifies, now give me more information. And here's what I want you to give me. Here's the PCR values I would like. Give me values for those PCRs. And that's when the client creates that big struct. And it takes those PCR values, it packages them up, it sends them, signs them, and sends them to the server who verifies them. And only if, after successful verification, the ticket is granted. So if you look at if you remember the Kerberos picture before, this is how it looks now. The initialization step is pretty much the same, except that now we have the AAK public key here, and we have these baseline PCRs compared to. The request comes in, and then this fail message it's called fail in Kerberos. So it's not that the verification fails, it's just with the fail message, what we do is the structure in Kerberos is called error message. So here we include request for PCR mask and a NOTS. And then the client responds with pre-authentication plugin, which makes the TPM code, signs it, and sends it to the KDC. And then the KDC responds, if everything is verified correctly, then it's just a normal ticket. And then if you see here, now the ticket is a normal ticket and everything else remains the same. Did you have a question? Or
how do I make sure that the Kerberos attack doesn't work? Testing the PC, you're giving out the ticket,
right?
And step 2 fails. Somebody publishes ticket now. I mean, you are tested device, and you can basically every other client, every malicious client, and publishes ticket.
Well, if you hold on till the end, I actually talk about that. But if I don't, then I'll answer the question at the end. So, like I said, we use the pre-authentication plugin. Basically, there's a registration process in Kerberos where you can pick this table of plugins and you just add your stuff, and then what happens is the Kerberos, when it starts the authentication process, it looks through its plugin table and says, well, do I have this? Do I have this? Oh, I have some code for this plugin, and it goes and executes it. So we made a lot of changes to the client and the server, and I'm not going to go through all of them, but basically it's all the creation of the codes, the request for the code, the verification code, and also some code to manage the data. Because the way you would get when you get the request for the client, you have to figure out what public key to use for this client. And so we have a database, and knowing the realm and the principal, you can look up what public key that guy has, and also what the golden value that we're comparing against is there. And so we have some sort of back-end, internal data storage stuff as well. So the demo is very short. I'm not going to show the provisioning of the client. We're just going to assume that the client is registered. So what the demonstration is, and I have to warn you that this is Kerberos. It's not very exciting. It's not supposed to have any UI at all. It's supposed to be all under the covers. You just connect and that's it. So we just put a lot of printfs into text-only windows, and so it shows you what it's supposed to do, and in reality that wouldn't be there. Obviously, this is for demo purposes only. So the demo is very simple. The first scenario is the client is successfully verified, and then we change the state of the client by modifying PCR16, and so then we show that here the client now is different, and so the request for connection is rejected. And as a warning, this is sort of what you're going to see, and I apologize because I think it might be just as blurry on the video. I actually have a little video of what's going on, but I'll walk you through it, and I highlight steps, and it's very short, it's no more than 3 minutes. So let me switch to okay, so if you see, we're running key init here. It already started, sorry. Back up. Great. Okay. So, I'll pause for a second, and I'll just technical issues here. I had to exit the, there you go. There you go. Okay. All right, so this is a server window, and like I said, I'll walk you through it. This is our little utility window where we can generate IKs, and the only reason why we have it here is it's value highlighted. This is PCR16, and so we show that right now it's all zeros, and then we'll show that it has another value. And then this is the client when we run kinit so that we can connect this client to this server. So let's start that. Okay, so kinit-b, so we're doing this. So, okay, so it says, all right, put in the password, and it says authentication to Kerberos 5 is successful. So now we go back and we start dissecting. So what happened here? So if we go up, you see here it says it's looking for a pre-authentication plugin. So checking PA data is the pre-authentication data, and so it looks and says, okay, well type this is TPM attest. So it has some code here that we have to run. So it starts requesting so this is the nonce that it says, and then this is the PCR mask. So if we go here to the client, we can see that nonce is received. And like I said, the reason why we use a nonce is so that you can't replay the same request again. So it's the same nonce. You can see it's the same one. And this is our gigantic PA data struct. And it includes the nonce. It also includes the golden value for all the PCRs. Go back here. This is what we receive. And this is the nonce again at the beginning. And then the golden value is here. So you see it says, okay, we found the nonce. This is it. So basically this means that we sent it and we received it here. So that means, everything got compared correctly. And then this is the signature. This is the signature that we're sending, and this is the signature that we received. And this is the gold, this is the nonce that we received, and then this is the golden value before the signature. And yes, that's the signature. Okay, so golden value is verified here and here. There you go. So verification for public key is the return value of 0, so the public key signature has been verified. And so now we say, okay, the signature has been verified, everything is correct, so we'll connect very well. So now we run this utility here, and notice that PCR16 now has a value. So we modified our code, so we try to connect using the client. And now it says, oh, no, that's it. Pre-authentication failed while getting initial credentials. So what we would show here is that the golden value sent does not match the one that is already on file. And so they verify them, they compare them and say, no, you did not send the correct thing, so I'm not going what we're sending, and but that is not what we're expecting. It's a different value. So now we go here and we set it to 0 again, just to make sure. We run it again, and it says, okay, fine, give me the password, and then it says, okay, you're fine, here's your authentication currently, because the quote now is correct. For some reason, I decided to start from the beginning. Okay. So basically, we've integrated the exchange, this initial exchange of pre-authentication, into an existing Kerberos protocol. This was a minimal performance impact because, of course, all of the performance impact would be the regular Kerberos exchanges. So this was just an initial step right now. Right now, the client is the only one that's required to have a TPM. We did use TPM for nonce generation, which is probably not a very good idea if you have a very busy server with many connection requests because the TPM is very slow, and I've actually had it recently where the TPM just ran out of entropy completely, and so then it was 2-3 minutes per request per key or something like that. So right now we used it because this was a very small test, but usually we would, in a real life implementation, we would probably use some other way to generate nonces. There's a lot of future work. This was a very short project that we did together. It was about 2.5 months. So there are a lot of different things that we would like to do. This was we just thought it was a very good idea. We would like to share it with everybody. So we would like to have a mechanism to prevent booting into a bad state, because, as you said, what would prevent me from taking this good request and copying it to a different computer and sending it again and again, and it doesn't matter what state you're in. Well, this is where we would like to look at tick stamps, which are provided by the TPM, and if you seal your measurements to that, if you seal your request to that, when you get it back, if you reboot it, your tick stamp changed, and so you can't decrypt the ticket that you get from Kerberos. And so that would prevent you from either booting into a different state after sending the request, or copying this to a different machine and trying to pass it along as a good state, trying to cheat the server into thinking that you have a good state. We would really like to also have cryptographic protection for both client and also have the server authenticate to the client, which it doesn't right now. We would like to maybe we'll look into integrating integrity measurement architecture measurements into the tickets as well. We would like to do obviously more software testing, because this was tested with 2 clients right now. We would like to do a lot and see how it works under a lot of load, and also test it with servers that are not equipped with pre-authentication plugins to make sure that it defaults to a normal operation. Because the nice thing is that with Kerberos, since it's implemented already and it's used a lot, it would be nice if it was backward compatible, because at least you could use the older version of Kerberos. And also, different PCRs, and not only the ones that we use. This was just something we picked. And right now, the server is requesting the PCRs, but it would be nice to have them included into the ticket. So maybe then the service that you're trying to access could dictate what PCRs they would like to see, for example. Now, we don't have the ticket modified at this point, but that would be a future something that we would like to do, because I think Kerberos has this infrastructure already pretty much. There are fields in the tickets that I think, and we would have to test this, but if you add additional information to a ticket, if some version of Kerberos gets this ticket and says, oh, I don't know what this is, they can just ignore it. So at least there would be some backward compatibility that way as well. We are a couple of versions behind, so it would be nice to create a patch so that we could just patch the latest version. And we would have to address the registration of the clients, of course, because right now we just, like I said, for the demo, I just did some hand waving and I said, assuming that everything is registered, then let's see what happens. But of course, registration is a big deal. Re-registration is another interesting problem to look at, because what happens if, well, if you are a user, you might be using several computers. So if you're using several computers, how do you do that? We would have to have a database that registers all of these to you, or how would that work? And also, what happens if even biases get updated? So we tied this to bias measurements, but what if you update a bias, even though that doesn't happen very often? Well, what if we do things like, let's say we use trusted browser, and it measures the initial RAM disk, it measures the kernel, and it measures the kernel command line arguments, for example. And it puts them into, I think, PCR 14 or 15 or something like that. I think it's 14. So if you seal it to that PCR, or if Kerberos requests that PCR, well, how many times do we update operating systems? If it's Microsoft that's on a weekly basis, and the Tuesday updates that come. I mean, how do you do that? So that's a very important issue, because how do you prove that this is my new old value? So you have to have a re-registration process. And again, since we are using signatures, we're using attestation identity keys. There's got to be some sort of a certificate infrastructure, because you have to validate. So, for example, Infineon and ST Micro TPMs have endorsement key certificates in them. So then you have to have some sort of a validation infrastructure that validates that certificate, and it says, it can go up the chain and say, yes, the certificate is valid. And minor things like looking at data, some sort of solution to have all this data stored in some efficient manner, whether it's using the Kerberos' own data storage, or maybe have something else, but it is something to look into as well. And if you have any questions, I have these are contact information for us, and that's it. If you have any questions. Yeah.
Personal curiosity, are you using the MIT Kerberos server?
I'm sorry, the MIT or
the Kerberos that they use MIT or
it is MIT. Yes. And of course, it's another issue if you have to integrate it into Windows, because Windows does use Kerberos, but it is a different version, and it's not open source. So this was tested on Linux. So that's partially why it's so important to have backward compatibility, because if you have another client that has Kerberos but has no such capability, but you should still, because Kerberos in and of itself is a pretty good system. So this doesn't take away anything from the actual Kerberos. It just adds another layer of security to it. So if we have another